Good evening. I am Pranav from CSCE section. Today I am going to present a PPT on the topic vector differentiation. So let's start. First of all, what is a vector differentiation? It is a process where we can find the rate of change of the vector and the valued functions, and it is an extension of the differentiation applied to the functions that output vectors instead of scalars. Now, vector is very important to understand in some particular fields like in physics, in engineering, in graphics, and that is a computer graphics. Vector and differentiation is very important in these fields. Next, vector functions. What is a vector function? It is a function that maps a scalar variable into a vector in a multi-dimensional space. There are some common examples like position vectors include which describes the motion in 3D space, and the notation for the vector is typically the bold symbols or the arrows or that indicates the vector identities. Next, differentiation of vector functions. It involves taking some derivative from each component with respectable to the scalar variable. Here we can see for a vector function, angle x of t, y of t, and z of t, and the derivative is x dash of t, y dash of t, and z dash of t. And this is a process where it yields a new vector which indicates the direction and the speed of change of the original vector function. Gradient of vector fields. What is a gradient? The gradient of a vector operator indicates the direction and the rate of the fastest increase in a scalar field. For a scalar field, for now we are not going into the scalar, but for a vector field, the it gradients a gradient provides a very crucial information about the field's behavior. Understanding the gradients is where in optimization problems like understanding the physical phenomena like a fluid flow. Next, there are a few applications, so let's get into that. Vector differentiation is applied in physics for calculating the velocity, the acceleration, the speed, and etc. of moving objects. In engineering, it is used to analyze the force and stress in structure and materials. As we go specifically, it is used in physical, in civil engineering. The stress and strain, the force in the component in the structure. In computer graphics also, the vector differentiation helps in rendering motion, like simulating realistic movements, like drawing a 3D figure in a computer, which uh, which look like a moving object and which looks like a realistic movements. Next, so let's see a problem. Prove that del into A vector into B vector is equals to del into B into A minus del into A bar into B bar plus B bar into del into A bar minus A bar into del into B. So let's see the solution. First, we have to find out the curl A bar cross B bar and sigma summation of I bar into dou by dou x into A bar into B bar, summation of I bar into dou A by dou x into B my plus. Elaborate this, and we have written it in this form, and after some summation we'll get the answer. This will get the summation of this, and the final answer is curl A bar into B bar is equals to A bar divergent B bar minus B bar divergent A bar plus B bar into del into A minus A bar into del into B. So we have proved this. Let's see the conclusion of this topic. And vector differentiation, it is a very fundamental concept which nearly extends to the multiple dimensions. And learning this topic is very important for the students who are in the science, technology, engineering, and mathematics field. And it has very wide-ranging applications. Understanding this vector differentiation can enhance our problem solving skills and in various courses. Thank you.